I just wanted to go back to our example 3. I made an error in the last video that I wanted to correct. In example 3, letters B and C, we made a slight error here. When we calculated the domain for B, we did a bit of inequality math here to figure out that x has to be less than or equal to 4. This satisfies the larger square root sign. However, we can't yet say that that is the exception, that x can be anything less than 4, because we have another root underneath here that also needs to be satisfied. We do have another restriction here. And from that one, we can say that the domain on the inside there is that x has to be larger than or greater to 0. So the final domain of this entire function is the combination. X will have to be greater than 0 and also less than or equal to 4 inclusive. In part C, we said that yes, x has to be greater than or equal to 0. That part was correct. However, when I went to write it in interval notation, I mistakenly wrote that it goes from, oopsie, negative infinity. I think I wrote something like this, from negative infinity to 0, or I'm actually not sure what I wrote in the last slide. However, it was wrong, so I need to correct it here. We have a root of a root. X does need to be positive, so the correct way to write this in interval notation is it begins at 0 and goes off to positive infinity. I think I had written that one backwards. So I just wanted to correct that error from the previous video. And for our last example, we have a triple composition. So f is given by x over 1 plus x, or sorry, x plus 1. Either way, it ends up the same. G is given off as x to the power 10. And lastly, h is given by x plus 3. So we're going to start on the outside and work our way inside. So the way I'm setting up this function is I start with something on the top in the x over something in the bottom in place of x plus 1. This is the f function, and I'm leaving the spots in place of x as brackets so that I can input the functions g and h. G in itself is the function x to the power 10. But in place of x, I have to leave again a spot to place the h function. So it's x to the power 10. And then in place of the x, I'm now putting in function h, x plus 3, x plus 3. This is the function f of g of h of x. So they all depend on x, but the way that we've built it is by making g depend on h and f depend on g. So I've put them one inside the other. In this case, I'd also need to be able to determine the domain. The numerator doesn't have any restrictions, so I need to look in the denominator. We need to make sure that our denominator does not equal 0. So let's take a look. X plus 3 to the power 10 plus 1 cannot equal 0, which means x plus 3 to the power 10 cannot equal negative 1, which means x plus 3 cannot equal the 10th root of negative 1. And we're never going to be able to have that anyway. So we don't actually have a restriction in the domain. So for this function, the domain goes from infinity to infinity. Or you can say x is part of all reals.